Hello everyone. This video is part of Java tutorial series. This video covers data types and literals in Java. The views shared in this video are only personal opinion. The video does not intend to hurt anyone's sentiment. Some of the information are gathered from various sources on the internet which might not be 100% accurate, hence recommend discretion. There might be some terms or acronyms usage that was not explained initially. Recommend to go with the flow. They will be explained in the later part when it is idle in the current video or the subsequent video of this tutorial series. In the last video, we learned about variables and different types of variables. We saw variables are reserved memory location to store values. That is, when you create a variable, you reserve some space in the memory. Based on the data type of the variable, the operating system decides what to be stored and allocates memory. So every variable has a data type. While I had declared a variable with several predefined data types, let's look at them in detail now. What are data types in Java? Data types in Java are of different sizes and values that can be stored in the variable. The different data types available in Java allows the programmer to select the type that is needed for the application. Data types are the building blocks of data manipulation. This brings the question, how many types are there? In Java, data types are classified into two large groups of categories: primitive data types, non primitive data types. What are primitive data types? As the name states, these data types are primitive in nature, that is, basic types without any additional features. Primitive data types have only single value and have no special capabilities. So, this means you can only assign one value to the variable created with the primitive data type. There isn't any methods or feature that can use to manipulate. In Java, all primitive data types are built in and predefined. Primitive data types always have a value. There are 8 primitive data types: boolean, byte, char, int, short, long, float, and double. As you can see, all primitive data types are in lowercase letters. All are keywords in Java and cannot be used as identifiers. Local variables of primitive data types are stored in stack memory. What are non-primitive data types? Non-primitive data types, also called as reference types because they refer to objects. Except for wrapper classes and string, non-primitive data types are mostly user-defined data types. They can have methods and can be used to perform some operations or manipulations. The first letter of non-primitive data types in capital letter. Example, string with the capital S, and if there are inner words will follow camel case. Non-primitive data types can be null. Non-primitive data type local variables reference is stored in stack while the object itself is stored in heap memory. The best example for non-primitive data type is the car object that I used in the last topic sample program. Before looking at each primitive data type, let's understand few things. I have been mentioning stack and heap memory in many videos. What are those? Well, they fall under memory management in Java, which is a vast concept. Hence, we'll create separate videos explaining memory management in Java. Having said that, I feel it is important to know at least the basics of memory management in Java to proceed further. Let's take a brief look at what they are. The JVM divides memory into two parts: stack memory and heap memory. Stack memory. Stack memory is a physical space allocated to each thread at runtime. Physical space means your computer's RAM. It is created when a thread creates. Memory management in the stack follows LIFO, last in first order, because it is accessible globally. It stores the variables, references to the objects, and partial results. Memory allocated to stack lives until the function returns. So, when a method is called, certain data is placed on the stack. When the method finishes, data is removed from the stack. At other points in a program execution, data is added to the stack or removed from it. If there is no space for creating new object, it throws the exception java.lang.stack overflow error. The scope of the elements are limited to their threads. The JVM creates a separate stack for each thread. Heap memory. It is created when the JVM starts and used by the application as long as the application runs. It stores objects and JRE classes. Whenever we create an object, it occupies space in the heap memory while the object reference is created in the stack memory. It does not follow any order like the stack. It dynamically handles the memory blocks. That is, we need not to handle the memory manually. For managing the memory automatically, Java provides the garbage collector that deletes the object which are no longer being used. Memory allocated to heap lives until any one event, either program terminated or memory free, does not occur. If the heap space is full, it throws the exception java.lang.out of memory error. The elements are globally accessible in the application. It is a common memory space shared with all the threads. Now let's look at the primitive data types in detail. Boolean. The Boolean data type represents one bit of information. There can be only two probable values, true or false. Default value is false. General syntax is Boolean identifier value. Byte. The byte data is an 8-bit or 1 byte 2 complement integer. The range is between -128 to 127. Default value is 0. Syntax is byte space identifier equal to value. Char. The char data type is a single 16-bit or 2-byte Unicode character. The range can be termed as character representation of ASCII character 0 to 255. General syntax char identifier equal to value. The int data type is a 32-bit or a 4-byte signed 2's complement integer. This data type is used as default integral values. The default is 0 and the general syntax is int identifier equal to value. Note, in Java SE8 and later, you can use the int data type to represent an unsigned 32-bit integer which has a value in the ranges from 0 to 2 power 32 minus 1. Short. The short data type is a 16-bit or 2-byte signed 2's complement integer. Basically, short is 2 times smaller than the integer. Default value is 0. Long. When we require a wide range than the integer is needed, where memory is the main concern, we use long. The long data type is 64-bit or 8-byte signed 2's complement integer. Note, in Java S8 and later, you can use the long data type to represent an unsigned 64-bit long which has a minimum value of 0 and a maximum value of 2 to the power 64 minus 1. Float. The float data type is a single precision 32-bit or 4-byte IEEE 754 floating point. Range up to 7 decimals. Whenever we require to save memory in large arrays of floating point numbers, we use float. Default value is 0.0f. General syntax float identifier equal to value. Double data type is a double precision 64-bit or 8-byte IEEE 754 floating point. Ranges up to 16 decimal digits. It is the default data type for decimal values. Default value is 0.0d. The notation in which we represent a fixed value is called literals in Java. Let's take a look at literals in detail. What are literals? In Java, literal is a notation that represents a fixed value in the source code. In lexical analysis, literals of a given type are generally known as tokens. Literals in Java are synthetic representation of Boolean, character, numeric, or string data. They are a means of expressing particular values within a program. They are the constant value that appear directly in the program, can be assigned directly to a variable. There are several types of literals in Java. Some of the common literals are integer literal, floating point literal, Boolean literal, character literal. Integer literals are sequence of digits. They can be further classified into decimal, octal, hexadecimal, and binary literals. Decimal literals require no further explanation. We have been using from our childhood. Can be represented as base 10. Consist of digits from 0 to 9. And examples. Octal integers use only the digits 0 to 7 with a leading 0. Examples. Notice that when we get past 7 and are out of digits to use, we are allowed to use only the digits 0 through 7 for octal numbers. We revert back to 0 and 1 is added to the beginning of the number. You can have up to 21 digits in an octal number, not including the leading 0. Hexadecimal literals. Hex for short. Hexadecimal numbers are constructed using 16 distinct symbols. Because we never invented single digit symbols for the numbers 10 through 15, we use alphabetic characters to represent these digits. Counting from 0 through 15 in hex looks like this: 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, F is 15. Java will accept capital or lowercase letter for the extra digit. You are allowed up to 16 digits in a hexadecimal number, not including the prefix 0x or the optional suffix extension L. You can see the examples here. Binary literals. Binary base 2, whose digit consists of the numbers 0 and 1. You can create binary literals in Java 7 and later. Prefix 0b represents the binary system. Example. Note: all the integer literals may also be specified as long by placing a suffix of capital L or small l after the number. Examples. Floating point literals. Floating point numbers are defined as a number as decimal symbol and more numbers representing the fraction. Example. Floating point literals are defined as double by default. So if you want to assign a floating point literal to a variable of type float, you must attach the suffix f capital or small to the number. If you don't, the compiler will complain about a possible loss of precision because you are trying to fit a number into a potentially less precise container. You may also optionally attach a D to double literals, but it is not necessary because this is the default behavior. Here you can see the first example. Without F, compiler throws error, possible loss of precision. The second one would work as expected. Boolean literals. Boolean literals are the source code representation for Boolean values. A Boolean value can only be defined as true or false. Example. Note: Boolean is left hand equal to 0 will throw compilation error. Character literals. A character literal is represented by a single character in single quotes. Example. You can also use Unicode character with the prefix /u. Also, characters are 16-bit unsigned integer under the hood, which mean you can assign numbers. Examples. The overall difference between primitive and non-primitive data types. So far, we have discussed in detail about properties like origin, storage, null values, and examples. These two, uncopied and uncopied change, was mentioned implicitly. What does that mean? Uncopied. When copy a primitive data type variable, two different variables are created with two different assignments, indicating separate memory allocation for both. So, when copied variable's value is changed, it does not reflect in the original variable. Whereas on copy of a non-primitive data type variable, two reference variable is created, but both pointing to the same object in heap. This means when the copied variable changes, the original variable also changes. Let's look overall example for all the things that I went through this video so far. For the example, I have defined the class demo data types. Within the void main, I am declaring and initializing primitive data type values and printing them. First one is a normal integer, then the different literal types. Then we have example for floating point, boolean, different character literals, and then one example for non-primitive data type. Here for the string object, I am defining as null and printing them. The one other additional example is for backslash literal. This slash t would give a tab spacing. Let's check the output. The octal hexadecimal conversion worked as expected. So are the other conversions. All the output values are printed as expected. Let's recap with a quick 2-minute summary. Data types in Java are of different sizes and values that can be stored in the variable. There are two major classification of data types, primitive and non-primitive data types. Primitive data types are basic types without any additional capabilities, have only single value. In Java, all primitive data types are built-in and predefined. Primitive types always have a value. There are 8 primitive data types: boolean, byte, char, int, short, long, float, and double. Local variables of primitive data types are stored in stack memory. Non-primitive data types, also called as reference types, types because they refer to object. Except for wrapper classes and string, non-primitive data types are mostly user-defined data types. Non-primitive data types can be null. Non-primitive data type local variables reference is stored in stack, while the object itself is stored in heap memory. The JVM divides memory into two parts, stack memory and heap memory. The stack memory is a physical space allocated to each thread at runtime. Memory management in the stack follows last in first out order. Heap memory stores objects and JRE classes. Whenever we create an object, it occupies space in the heap. It does not follow any order like the stack. It dynamically handles the memory blocks. Primitive data types. Boolean is 1 bit information, either true or false. Byte is 1 byte signed 2's complement integer. Char is a single 2 byte Unicode character. Int, short, long are signed 2's complement integer. Int is 4 byte, short is 2 byte, and long is 8 byte. Float is a single precision 4 byte IEEE 754 floating point. Double is a double precision IEEE 754 floating point. Literals. In Java, literal is a notation that represents a fixed value in the source code. They are a means of expressing particular values within a program. They are the constant values that appear directly in the program, can be assigned directly to a variable. Some of the common literals are integer, floating point, boolean, and character literals. The integer literals can be further divided into decimal, octal, hexadecimal, and binary literals. After every topic, there will be a set of questions with multi-choice options which you can use to self-check your skill on the topic. These are derived by me for the topic. I will post the answer on the comment section. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the program efficiently. First question. State true or false. Instant variables of primitive data type values are stored in stack memory. Choose the correct statements. The options are given below. Identify the wrong literals. The options are given below. Practice makes you better. You can master any programming language if you keep test coding. For every topic, I will list out the programs for you to try out. Write a Java program. Assign values to all primitive data type with all possible literals and print them. All the best for the tryout. Thanks for watching this video.